Need a packet? Oh. All right, so we're on the back of the first page of the intro to sequences and series, and we're going to talk about explicit formulas today. And an explicit formula is a rule in which the nth term is defined as a function of n. And we're not going to use the previous terms. So if we want to find the first term, you're going to plug 1 in for n. And then when you want to find the second term, you're going to plug 2 in for n. So that's what we're going to do on some of these examples. I'm not going to do all of them. I'll do as much as you guys feel like you need me to do on 7 through 12. So on number 7, if I want to find the first term, which is represented as a sub 1, I'm just going to take 1 and put it in for n. And then just figure out what that is. So inside, that's negative 2. Negative 2 times 7 is negative 14. So that's the first term. So just plug it in like it's a function. And then to find the second term, I'm just going to plug 2 in for n. And inside these parentheses, I get negative 1 times 7 is negative 7. All right, and then for the third term, I'll plug in 3. Fourth term, I'll plug in 4. We're finding 5. All right, and then the fifth term, I'll plug in 5. So it's a totally different way to represent a sequence. We're still going to get a list of 5 terms. You just find them differently for explicit. Now, what I feel like a lot of my students like to do on explicit is just put it into the calculator and then get the list from the table. So I'm going to show you how to do that. If you want to do it that way, it's way quicker. So let's do that for example 8. So what we'll do is go to y equals. And then when you type it in, you're not going to put n in. You're just going to use x. All right, and then when I do 1/3, I am going to do it as a fraction. So alpha y equals, and then choose number 1. If you do it another way, it's still going to give you answers. It'll just be decimals. But it'll be all right, so after you do y equals and plug it in, then you're going to go to the table. So that's second, and then graph. All right. Now, any of these x values that are less than 1 don't even make sense. Like the negative third term, that doesn't make sense. So all we do is we scroll up or down.
How'd you change it in fractions?
It's alpha. Oh, sorry. It's second y equals. Nope, it's alpha y equals. You got it. You got it. The first one. Did it work? So alpha y equals, and then number 1 is n over d. That just means a fraction. You have to type it in originally that way. Okay, I got you. All right, let's go back to the table. All right, so scroll so you see 1 through 5. 1 through 5 are your term numbers, and then all those Y's are the first 5 terms. All right, so you're just going to use the Y's for the X's that are 1 through 5. And so what we had there were 1/9, 1/27, 1/81st, 1/243, and 1/729. The other option is we could just one by one plug in 1, 2, 3, 4, 5 until we got those fractions. However you want to do it, it doesn't matter to me. This definitely is faster to use a table. All right, let's look at 9. I'm going to do it on the calculator. If you want to just plug 1 in and plug 2 in and plug 3 in, that's fine. So we'll go to y equals, change it to negative 4x squared, and then go to the table. All right. Now our table is where it needs to be because of the way we did the last one, but those y's are the first 5 terms. So totally different than yesterday. Now we just plug in numbers instead of using previous. All right, so I'm going to skip down, unless you guys need to see some more of those examples. I'm going to skip down to number 13. This is where this is kind of tough. We have the sequence, and we're going to write the rule. But the rules we're going to use is you plug 1 in to get -7, and you plug 2 in to get -9, and then plug 3 in to get -11. So let's do 16 first. All right, so on 16, you're going to plug 1 in to get 1, plug 2 in to get the square root of 2, plug 3 in to get the square root of 3, 4 in to get 2, and 5 to get the square root of 5. I know it's weird. So what would you do to each of these numbers to get those? What? Take the square root. Good. So it's just the square root of n. Okay. And so the next 3 terms, we put 6 in, we get the square root of 6. Plug 7 in, we get the square root of 7. And plug 8 in and get the square root of 8. All right. Let's look at the next one. It's kind of tough. Okay, so on this one, we're going to plug 1 in and get 2, 2 in and get 5/2, 3 in and get 3, 4, 5. I'm going to give you a little bit of a hint over here. All right. On all of these, they're all something over 2. Okay, this one's obviously 5 over 2. This one's 7 over 2. All right. Now, what would we do over 2 to get 2? 4. So 4 over 2 is 2. 6 over 2 is 3. And then 8 over 2 is 4. All right. So my rule is going to be something over 2. All right. Now I need to be able to put 1 in for n and get 4 over 2. And then put 2 in for n and get 5 over 2. So what would you do to n to make it a 2 and then a 5 and then a 6? Well, what I'm putting in is a 1. So I need to do 1 and then something to get 4. And then 2 and then something to get 5. Does that make sense? 3 and then something to get 6. So what would you do to it? You would add 3. I know it's not easy. All right, so the next term, to get the 6th term, I would put 6 in. So 6 plus 3 over 2 is 9 halves. And then 7 plus 3 over 2 is 10 halves, or 5. And then 8 plus 3 is 11. And then over 2. Plus 2. All right, let's look at 13. What do you notice is happening each time on number 13?
Subtracting 2.
It is subtracting 2. So we're not going to write it that way, but we are subtracting 2 each time. And we're not going to do recursive. We're still going to do a sub n. But there's a little trick I'm going to show you. And we'll learn this better later in a couple days, I guess. But whatever is going down by the same thing every time, that number is going to be in front of your n, multiplied by your n. So because we're subtracting 2 every time, that's going to be in front of the n. Now, this isn't quite done because I need to be able to put in 1, multiply it by -2, and end up with a -7. So I'm going to have to do something else to it.
Subtract by 5.
Subtract 5, good. So it's -2n minus 5 is the rule. And again, I'm going to teach you an easier way to do that in a couple days. So this is just an introduction. So don't freak out on me, please. All right, so we can just continue subtracting 2 if you wanted to. That would actually be easier. Or we can plug in 6, 7, and 8 to get the next 3 terms. All right, one more, and it's tough. If you figure this one out, I'll be pretty impressed. All right, this one, we're not adding the same thing each time. We're not multiplying by the same thing each time. So it's going to be like a completely different type of equation that we end up writing, different type of formula. So things that you can do is square, cube. You can do square roots. You can do, I'm trying to think of what else there might be. You can do fractions. This one obviously is not a fraction. So I'm going to give you a hint. It is going to be a square situation. But we are going to have to do something else also. And I'm going to need to be able to put 1 in for n, square it, do something else to it, and get 3. And then put 2 in, square it, do something else to it, and get 6. And then it's adding 2. Good. All right, so those are all 2 more than actual perfect squares. All right, and then let's see. I will go ahead. So that's sixth term. I square 6 is 36 plus 2 is 38. And then 7 squared is 49 plus 2 is 51. And then 8 squared is 64 plus 2 is 66. Okay. All right. So today you're going to have 4, like the first few examples, and then 4 like these where you write the rule. Please don't get frustrated and give up. If you want me to help you find the rule, I will definitely help you. All right, and this is on that same homework page. I want you to do today 7 through 14. And you can tell on some of them I did change it a little bit.